Okay. I'm eating. So I apologize. But it is time. Now, this stream is going to be a wild card stream. Not really sure what I'm going to do. Right now I have it under WoW, but that might change. I still am feeling it out. I'm thinking about maybe coding a little bit. I have not set up anything. I have a bunch of scenes in my OBS, but the problem is I don't actually have anything that seems to, in my opinion, make the VS Code look good. At least nothing that I completely solidified with. So like if I open up VS Code right now, you know, it might not look the best. I'm still trying to figure out what I like. So this is my capture for VS Code, and here it is. Here's VS Code. I don't know if I'm too big, too small, you know. I want to change it up. I was inspired by a YouTube channel called Pirate Software, actually. And kind of wanted to see if I could stream while coding. I've never done that before. But before I do that, I wanted to do a little bit of shopping for stream gear. So first, what I'm gonna do is I'm gonna open up Twitch and we're gonna do a little bit of window shopping. Now hopefully my mic and stuff carries between these scenes, because I put a lot of work into carrying things across. So I can already see that this is all jacked up for Firefox. So we gotta fix that, that's for sure. Here we go. So let's say, oh, okay, resolution wise, this is not 16:9. This is my 4K monitor, so this is a different aspect ratio than I was expecting. So what if I did this? Let's aspect ratio that. See, yeah, that's what I thought. None of these are really 16:9, which that's what OBS wants to use. This is probably the closest I can get. Dang. What if I I'm thinking I I widen this like so. Okay. So the downside is I can't just do like a monitor capture, because this is my, like this whole width is the monitor. So like it's gonna pop up very thin. Like this is what it would look like. If I go over here and I do a video capture no, wait, not video. We want display capture. This is gonna be like something like full display. Full display. This is what it looked like. Okay. So I mean, it's gonna be a little bit of an inception going on, but like here I am. There's my whole display, this whole width. So if I make this whole thing fit on the screen, that's like half of the screen. Okay, hold on, here we go. Yeah, that's literally half of the screen. So, I mean, it could work for some stuff. So like, let's say, I don't know, I wanted to go to the section for like coding. So I think I just look up software and game development. And I mean, it's yeah, I mean, it's pretty small. It's pretty small. Like it would have to be something where I'm not zoomed and looking in on small little tiles. It's big on to me, but on the stream it's pretty small. So let's click on this top one. Let's see. So this is full screen. I'm gonna mute it. Of course, this is an ad, and even that, like, this is just like a tiny section. So I think what I do is I do this just like a normal streamer would. You know, it shows just the window. It's a little annoying for switching back and forth, but I think it's the most accurate. So that's what I'll do. But before I can do any of that, I need to. Oh, of course, there's a Windows update. I'll have to do that later. But I need to use this feature called Power Toys. Sorry, I needed the name to pop up. Wasn't actually sure what it's called. And what that allows me to do is make these silly little crops where I can change my tiles on my monitor. And like this, I wish I could just show, but it's just a little bit too odd. So to me, this looks like this guy is making a video game. And then actually look. Okay, yeah, this is definitely a mini game. Damn, look at all those sprites and models and assets. I wonder what game engine this is in. Unless he made it himself. Let's see, let's read a little bit. A crank session. That's kind of cool. He times himself down. Oh, but he already hit 3 hours, so is his timer up? That's not a bad idea though, timing it. But if that takes too much energy, I'll stop and focus on programming. At least he's honest. Like he's just programming, not really having to chat too much.
Probably got double moved, but that doesn't really matter. Things look fine.
Yeah, he's just sharing his idea. That's pretty cool. That's pretty cool. Like I'm looking at the chat of this, and it's just like people talking about coding and stuff. You know, like that's respectable. In fact, I should follow this category because I didn't know that it was its own. Gaming and software was its own now. Before, you had to go to just science and tech, which is good, but it's still too vague. Not too vague, but too wide of a category for all the stuff that could be possible under that category. Okay. So what I need is Fancy Zones, this app called Fancy Zones. So what I will do now is widen this. There we go. Save. Okay. And let's get rid of these zones. Control tab. Merge and click and drag across the zones. That's the same. Delete. Delete. Oops. No, that's not right. Control tab to focus. Arrows. That's for resizing. Not quite sure. I wish I could just like right click on it, but it's not doing that for me. Oh wait. Hold on. Shift S to split it. Ah. Oh, okay, I gotta hold it down. Maybe. It's, oh, okay. It worked. I think it's just a little bit slow. Ah, okay. There we go. Now we got one. All right. So if I do this, I can close that out. And then I can come over here, come down here. We don't have any music, so that's one of the things I planned on doing. I planned on adding some music. I'm also curious to see like what is the span of stream topics. So we got indie maker, indie game dev. This one just says dev. Let's see what they're deving. Let's see. They're using like Tmux or something here. This is definitely some Linux, Arch Linux stuff. We got some Git stuff here. So that's their Git history. OSU. Okay. Are they programming some add-on? Where is your my camera? Oh, my hair. Oh, my hair. Yeah, it's gone. My hair's gone. I got donated. It should have, but unfortunately it wasn't. I'll cut it off. I did. It's all gone. Now we are BTS. BTST rich. My face? My face? What about my face? It's the same. My face didn't change, I just have the mustache. Oh, shave it. I see. No, not yet, not yet. I'm doing something. I'm doing something, okay? I'm gonna let the stash, you know, chill for a little bit. Because it is an iconic look too. There's a lot of fans of the stash right now. It's the talk of the talk. In terms of this person, looks like they are just a OSU gamer maybe, and developing some stuff for OSU maybe. No, it's not. It sure is. It sure is. This guy's coding for something. I've seen this guy's YouTube videos before. They've been pretty entertaining. I think he is usually a Rust guy. Yeah, I know that he mentioned he worked at Facebook or something like this.
Do you have any food allergies? Well, my teeth are sensitive to cold.
Progressive can't protect you from becoming your
But
parents, but we can protect your home and auto when you
of course we gotta watch his ad.
1945. Oh, I'm just paying for my own salary.
Good old Twitch.
Type 1 is being defined here.
TypeScript. Okay, he's doing some TypeScript programming.
Diagnostic message is being defined here.
I'm just trying to figure out what he might be making. He's making some test cases for a compiler.
Which 0 gets expanded to this. I need to write some checks, I guess.
Yeah, so his tests are testing out some code in TypeScript. Not sure what his project is just quite. It looks like he's hacking a JavaScript linter, which if you don't know what a linter is, it cleans up the code. You run it through your, you give it a folder or something, and the program will clean up all the code for you. Make it so there's no white spaces, there's no misalignments with the brackets, that kind of thing.
See, there you go. Type is
Okay, let's go back to browse, I guess. All right, we need the followed categories. Is my thing on the side here showing followed? It's just channels. We will go, yeah, we'll just have to search for it again. And then here. So I'm mostly looking for the people that aren't game deving. So like the last guy was an example of somebody not game deving. Because I'm curious who else might be doing embedded stuff. Because if there aren't many embedded people, I'd love to show some embedded stuff. I'm mostly checking things out. He's coding at Rust.
What in the shit?
This is a Rust developer.
Escape the quotes. I'm a JS guy. I would just change to a different one of the 3 backticks. Or the quotation marks that are valid strings.
Okay, so he's making a game, I think. Building Space Drive. Not sure what that is.
Escape the quote.
Maybe it's a game.
Slashes, I swear. I swear that's how.
Let's see, get Mac device.
Oh, okay, it's the same thing. Gotcha. My bad. I'm good. I'm
He's
good.
polling for the
I'm
computer.
good.
What kind it is. Not really sure. Just trying to figure it out.
Okay.
Holy crap, did you see how many VS Code windows he had open? Oh, he has some TypeScript stuff going on here.
Or I'm gonna imagine it's like a MacBook.
He's got some different OSs here.
Oh. wait, no,
Engineering,
it's
more
Mac
documentation,
Studio.
launch space drive,
Mac
Explorer.
Studio.
Yeah, I'm not too sure.
Wow.
I'm seeing a lot of space drives. I should probably open up if he has... Oh, he's got a company. Now I work full-time on my new company, Space Drive. This is his company. Oh, he's making a file manager.
Regret.
Okay. This is a cool website. You know, it's reactive.
Let me try.
Roadmap. Where's he at right now? Media view. Turn any directory into a camera roll, including media from sub. So, like, using the idea of files from Linux, probably. And making everything look like media. This is interesting.
Yeah, you're right.
Hope it works out for him. We're gonna go to the next person. Mostly just curious, you know?
There it is. Model name Mac Studio.
C++, Fallout 2 modding tool. Okay, so we got some people doing mods. A Twitch extension. This person's just studying. Person's not unit. This person's deving. What is this? What is this tree? This 3-dimensional tree.
Great quote, Billy.
He was building this Tetris tree. Okay. Security Live.
They're not twinkling.
I turned him
And
down
why?
a little bit. It's got a lot of white noise.
I could,
Information security tools.
Yes.
So this is a kind of like a capture the flag security, cyber security kind of streamer. Pretty cool. That's a cool tree. Oh, he bought it from somewhere.
I think it's the angle of the dangle.
Got a toy box, 3D
Well, you
printer.
can kinda
See,
the
this is one of the
dangle
best
here.
parts. You can look and see the setups of these people.
Says, what's Christmas without twinkling lights?
Sometimes you get some creative ideas.
Here, let's see what happens if I...
Oh, he's got a big mixer
Wow,
here.
one plug, actually one...
These are some nice racks too. This is something you'd see at a company. Huh. That's pretty cool. Let's go back.
Doing what Mama says.
I think it's the back arrow.
Says.
Yeah.
Now it's boring.
So we got an MMO game dev. We got... What is this? What's on the left here? Life is hard, but not as hard as AOC, LOL. What is AOC?
Just a lot on my mind.
Looks like she's learning stuff.
And it gets tougher with age.
Skills learned in stream. Portrait, digital art, Python, Blender. So somebody is practicing stuff?
Wait, is this all a dream?
I'm not sure.
Amy being my dream.
C# Unity. Ah, it's a game dev, likely.
I said biggest.
Likely. Oh, what the heck is this?
Quick and dirty. In theory, you could set an eye counter.
I think these are like leak code problems. Day 3. Advent of code. Okay, so you're trying to solve different coding problems each day. Okay, for the month of December. Classic little calendar challenge.
It's Advent of trying.
Advent of calendar. Ah, AOC I think is what that is.
It's Advent of
Okay,
trying.
that's fun.
I'm so
You know, because everybody can try that. That's pretty interactive. That's not a bad activity to watch. Game devs, lots of game devs. Advent of code. Okay, some of the people doing that. Some Rust guy. Dev portfolio. So he's doing web coding. I'm not seeing too many. When's the next lull session? Probably when I hit level 25 and WoW. Right now I'm level 19. So it'll be, you know, perhaps next week sometime. If there is a small session. Oh, congrats. Congrats that is your last final though. That's pretty huge. Oh, I'm gonna make chat a little bit smaller. I realize I don't really have a good spot for chat. And also there's like no backing. Maybe I should make some kind of backing. Background color. Right? Make it black. Let's see. Debatable if there'll be a next semester. Oh, you don't know? You don't know if it was enough? I mean that's your last final, hopefully. You know, it's been a long time coming. Surely they'll just curve for you. Depends on the curve, exactly. I think the curve will go in your favor, Ken. I cannot for the life of me find the chat button. Here we go. No curve, you're screwed. Well, there's gonna be a curve. I just have a feeling. There has to be. There has to be. Alright. Hide common bots, browser settings, control audio via Streamlabs. Nope, not looking for that. TT. It's okay. It's fine. I think you'll be fine. Why is the background color only black? You're gonna go shower and play League till your eyes fall out. That sounds awesome. That sounds like a great way to celebrate you finishing. I think that's huge. Yeah, so this should be... If I put it all as white and I test out my chat, I'm gonna type test. I gotta log into Twitch. Man. Okay, hold on. Let me. Oh, what's this? Ooh. Okay. This is fun. Top stream reached 9 viewers. That's pretty solid. That's a lot of chats. Is that from me? There's no way 1.2 thousand chats were sent? That seems like a lot. English tier. Oh, okay, that makes sense. oh, we got the sick T-Rich T-Doc. Oh, I see. In my clip, yep. Affiliate unlock, some achievements, channel points. 17 new followers. Okay. Loudest fans is Sean. That makes a lot of sense. Sean, Kent. You know, I would have imagined that Zess would be higher up, Johnny, Heathcliff would be higher up, but Sean, that makes a lot of sense. What's the viewer one? I mean, I don't really view much, just chatting. Wow, that makes sense. These make a lot of sense. Chatty chatter. I mean, I don't really... Oh yeah, Zach Rar. 3 hours. 3 hours. Rad Scorpion. This is from the Major, Korean, friend, and Emaru and Zachar for the WoW content. Interesting. What is community? Oh, this is overall. Okay, I see. That's kind of cool. I never looked at that, so that was neat. But let's go back. What we're trying to do is make my chat look good. So if I go to just my channel and I turn off the sound so that way we don't have, you know, echoes. Okay, I don't know why it shows all this. I'm not really sure. Whoa, this inception is kind of crazy. All right. Yeah, I don't know why, but I just will always have a transparent background, I guess. Which is fine. That's fine. Don't really need much. So we'll bring this back down to 0. I should probably update my title because I don't know if I'll be playing WoW right now. I think I might just code. Firefox, Discord, web audio, alert box. Yeah, that seems fine. That seems fine. Remove that. About web browser. Okay, we'll just close out of this then. So we didn't see too many embedded people. So what we're gonna do is code in VS. We're gonna swap back over to this. I think what I'll do, well, let's make sure chat works actually. Test. Log in. Let me just log in real quick over here. Oh, wrong password. All right, got a tech. Oh man, it just signed me out. Dang it, didn't mean to do that. Oh, must have mistyped. Okay. Remember this computer for 30 days at least, then sign in. All right, now we're in. I'm gonna type test. Oh, it's way over here on this one. All right, so if I delete chat on this screen and then re-add it, also my face I feel like should be just a tad bit bigger. Something like that. You know, so I could actually see, you know, see the person that is talking to you. Now let me add chat. It's a dead silent stream right now, but that'll change in a bit. Where is my chat? I think this would be widgets. Yeah, here we go. Widgets, chat box, add new source maybe. Let's try this. We can customize it a little bit, maybe. Actually didn't really change much. I wonder if a majority of this is because like they show an example of something that looks way nicer. Oh yeah, we're gonna close that. We're gonna remove that chat box. We're gonna add our old one that looked a lot better. Selective recording. It's new. General chat, alert box, chat box, chat highlight. Oh, that's the people who highlight. I see. That's source. That's source. I'm gonna test again. And there we go. So if I was a viewer, I probably want this to be up here, I guess. I mean, it's kind of small. This is a test. We're gonna make this a long message. We just want to see how it looks. I mean, it's fitting on the frame. You can kind of read it. It's not really in the way of the code at the moment. So we'll just keep that up there. I think that's fine. The question is VS Code wide enough? You know, am I zoomed in enough? I mean, this is pretty viewable. On mobile, I don't know, but it's definitely viewable on this. So we'll just keep this how this is and get used to it. Yeah. So now that that's set up, what if we, oh, look, we have an update. We'll update that. While we're setting this up, we're going to change our stream title. I debated a little bit because I didn't quite know what my stream was going to be. But we're going to change this up to be not WoW, unfortunately. This is going to be coding. So this is going to be software and games. Software and game development. We're going to change this to be English, STM32, C, embedded. Should I do embedded systems? I can only do one. Let's do embedded. That looks fine. We'll change our title. Developing STM32 embedded library for future projects. Description: STM32 board support package for future projects. All right. There's nothing fancy about my setup. You know, there's no fancy fonts or anything. It's just code. It's just VS Code, but that's fine. That's totally fine. So let's open up our browser again, make sure our title changed, because I don't really know if it does sometimes from OBS. So let's go to Creator Dashboard. How about this? We'll go back to Twitch, go through the viewer method. STM embedded library for future projects. Okay, so that's good. Let's go to YouTube then. Make sure that's good. So let's go THCS YouTube. So that way, no, not tricks. What the heck is that? THCS. What? Okay, let's just go to YouTube. Then THCS. Okay. STM32 embedded library for future projects. All right. That's all set up. We are all set up. Are you going to make some art? Maybe some code art, if you know what I'm saying. Yeah, I mean, we can make a little bit of art, you know. Like this. We can make some art here. Just like this, you know, right down here. We can make some nice art. Oh, hold on. How do I make it on the other side? Because I can make it here, but these are not facing that way. Ah, I know. We got some ASCII art here. There we go. Is that the art you're looking for? There it is. There it is. Right there. New Twitch terms of services. Is that even what it stands for? I don't know. But yeah, anyways. All right. I do not know what my game plan is in terms of the actual code today. But before I get into that, let me put the music on. Because we can't code unless there's music. That's basically the basic problem here. So let me go to Epicenter. I think that's one that I have for royalty-free music. Epicenter royalty-free. Epicenter pictures. Just so, here, let me swap over to web browser. So that's what I'm looking up for. No, not this. Let's see. royalty-free music. Royalty-free music. You can see I searched for it before because I kept getting demonetized. Upbeat. Soundtrack. Where was it? Wasn't there a epicenter? That's why it's not epicenter. It's epidemic. Epidemic is what it's called. That makes so much more sense. Okay. So what I'm gonna do is change this to VS Code because I don't want to dox myself. So let me just log in real quick. I should probably change my VS Code to be like rainbow or something because it's a little bit tough to figure out what exactly is going on with this monochrome kind of, you know, color scheme. But let me just check if I'm allowed to play music without it hurting my channel. Signing up as a business. Not sure at the moment. Honey is giving me a sick discount, I think. How's everybody doing? I'm just filling in the empty space right now before I get into this. Got viewers on YouTube and Twitch, it looks like, which is pretty cool. Oh, that's the wrong app. What's up, Rich? You just getting STM? Yeah, so I've been messing around with STM stuff for maybe a year, let's say. About a year now. I started off with doing HAL, you know, just like basic example projects. I made a really simple STM synthesizer using push buttons, but nothing too crazy past that. But now I'm at a point where I want to make my own library for all my projects going forward. So it's basically just a from the ground up library. I'm debating how deep I go into like the testing side of it and stuff, because I kind of want it to be mimicking a more professional library, let's say. And it's also practice for myself too. Interesting that I can't speak. Epidemic Sound only works on YouTube. Oh, and Twitch too. Twitch is good. Oh, you freeze on Twitch, but not on YouTube. Interesting. Okay. But how about you, Bob Joe? Oh, Bob Joe. I just realized I know you. I know you, Bob Joe. I don't want to dox you, but yeah. Working on my library. I'm picking a song right now because I'm logged in. So we need some background music. And this place apparently has a bunch of free background music. Yeah, that's right. I remember you mentioning it. You had your class with the USB driver and stuff. I mean, that is eventually my goal to get to there, but right now, I mean, my main project is not too ambitious to be using the USB drivers. I'm gonna go with, what's the electronic sounds like first? I'm not sure how loud it's gonna be. Let me look at my mixer on stream as well. Okay. I am going to swap over real quick. Just need to safe list my Twitch chat or Twitch account real quick. Oh, stop the music. Okay. Okay, we're good. Back to music. I mean, that music's fine. It's nothing too crazy. It's like cyberpunky a little bit, background music that would go while you're doing a mission or something, you know? Do you know about the STM Cube ID? I do know about it quite a bit, actually. Let me put this off to the corner. Because I used it to solve quite a few of my problems. Use it to initialize some of my projects. The IDE. Okay, so the IDE I used for the first examples, but past that, I preferred doing my own. I just realized there's no music going through. Hold on. I preferred using VS Code because then I got a better understanding of everything that's happening behind the scenes. So I'm kind of taking that angle right now. Audio output. Is it output? No, I need an audio source. Hold on. I'm trying to figure out how to put the music back through the stream. Ah, here we go. Audio capture. And then we go to web audio. There it is. Okay. It might be a little bit loud. I might bring it back down a little bit. I don't want it to be too, too overbearing. Good it. It's less of a send code into the void and hope it works and more so actually getting to travel stuff. Yeah, I mean, trace stuff. Okay, that makes more sense. Yeah. Like the start of it was mostly getting a lot of my familiarity with the tool chain and like how do I flash and erase the STM with just like command line tools and stuff. And then I got that down. I was looking into how to make a debugger work on it and do line by line debugging through the command line again without the IDE, because then I actually know what I can do and I'm not dependent on the IDE either, so I could like carry it over to the other chips too. So that's been a little bit of what I've been doing over the last few months, let's say. At this point, I'm just writing my GPIO driver. I still have to finish my dinner, so you may notice me go off camera to get a bite. Look at that green screen in its full effect. All right, so what we're gonna do first is kind of update where we're at. Actually, let me turn down the music just a little bit more. If I can find the volume button. Here we go. The UI on this is a little bit clunky. Alright, so we're in our repo. We're just gonna go ahead and pull. Because, oh, alright, I guess I'm up to date. Never even thought about that side of development stuff, especially since I was doing it in class. I was more just concerned with getting the project done on time. Yeah, absolutely. Like when you're in school, that is a big part of it. Just doing the assignment and moving past it. A lot of times they give you the boilerplate code too, so you can just start right into the meat of the project. Maybe it's not the case for your project, but yeah. When I was in school, there was a PowerPoint presentation that kind of just like told you exactly what to do from a theory point of view, but told you what to kind of do from a theory point of view and then give you example code, and there wasn't too much creativity required from you. There's a lot of just look at the PowerPoint, do the assignment, and then move on. But like I didn't retain much of that, so when it comes to my actual job, my experience with writing drivers and stuff was not too much, and I had to heavily rely on any personal research. And even then, I still like have a lot to learn, but you know, that's fine. Okay, I need to like get my bearings a little bit straight here because it's been a bit. I'm not even in the right repo. So in short here, I have some Blink examples that I've been using to like kind of set up my code, set up my initial functions and stuff. I've been going off of the Google formatting standard that they have for C++ because they just have it online. I'm using that formatting style. I want to maybe set up unit tests. It'd probably be better to do it at this stage when I have very basic examples than trying to apply it to the more advanced stuff right away. But I think I need to do that off stream because it's going to take some behind the scenes installing, not installing, but just like formatting, and I don't really want to get into that right now. So I think what I'm going to do is kind of flush out some more of my GPIO and then like flash it on my STM here. Most of it's going to be blinking, but you know, showing it off would be pretty cool. It actually comes out not too bad on stream. I'm a little bit surprised. I was worried the green screen would take it off, but because it's a solid white board, you know, that kind of makes it a lot easier. But yeah, here's our development board. It's pretty thick. I'm used to ones that are like half the size from STM, but this one is pretty solid. I got it specifically because it has this USB-C port on it, which isn't on too many of the STM dev stuff at the moment. Okay. So, I remember now. Okay. So this is my first stream doing coding stuff. One thing I need to figure out is the showing of my datasheet, because datasheet reading is a big part of this, and I don't know like how much I want to show that on stream just because it's like super fine text and maybe not the most neat thing to look at. So what we'll do is kind of like just show VS Code. I'll have it off on my side. I'll read. If I see something like, oh, aha, this is exactly what I'm looking for, then maybe I'll show it on stream. Bring it up and be like, okay, so this is the register we need to manipulate. I'm still trying to figure out what kind of PDF viewer I prefer. Right now I'm using Adobe Acrobat. But I heard there's like, you know, a little bit of an online debate on what to use. Some people don't like to support Adobe because of their closed source nature. Other people like open source. Some people also don't like its UI and like features it has for finding stuff. It's maybe not the best. It works for me at the moment. It is what it is. I wonder if I got any brighter. I opened this document and it's white when everything else around me is all dark and black. So our task, we want to make an interrupt for our device. We want to set up a timer. So I remember now. I was making a timer library, and it's bare bones right now because I just was creating it for the sake of having it there. But for this, we're gonna need to initialize our timer. So it looks like I started with making a function for initialization. And so far, like my main method has been just returning some negative ones. On my functions, I might change that later on, but when it comes to a function, I kind of want to see if it passes or not, and be able to do that just within the library itself. So in it itself, we're going to do timer. We're going to pass a word named timer here. In it itself, we'll need to go in and turn on certain clocks within, you know, the chip. We're going to need to go to, hold on, I need to pull up my table of contents. The real clock. This acronym is RCC, Reset Clock and Control. There we go. I think we need to go in here and enable whichever clock is supplying to the timer that we want. So in our project, I guess we have to think about that scope. In our project, we want to make our timer go at whatever milliseconds I provide to it in this function. We'll probably have a different function called set time, something like that. And the granularity of it, I have to see how fine I can go. I'm gonna guess it's based off of my clock itself on the chip. This chip, I believe, can clock to 160 megahertz. So probably not that at its lowest or fastest, interval for a timer, but maybe something a little bit more reasonable. Like, I think 60 hertz or megahertz is what I can access. This is where the STM Cube IDE would become helpful. Not the IDE, but just the Cube app itself. It's separate. It's this whole GUI page. I think that would be a lot more helpful for something like this, but I guess what we can do is just see if we can make it blink using a timer and just start from there. So, I mean, I guess I could show. Let me try this. I'm going to do a window capture where I pull it up just onto the side and see how it looks on stream. Give me one moment. That is not what I meant to pull up. That's just the same window. We want general window capture. What I needed to do is make a new source. Here we go. Sumatra PDF viewer is pretty good. Okay, that one I haven't heard of. I've heard of this like something Fox, not Firefox, but something like Foxtrot or something like that. I remember I was in a Linux environment. Actually, no, that was Windows. That was on Windows too. But I remember seeing something about a Fox. Okay, so this is going to be datasheet, or let's just try Acrobat. Let's name this Acrobat. Okay. And so here's our data sheet. Checking my OBS settings. Okay, so we have a data sheet here. I might just like toggle this on and off. I'm not sure just quite yet. So obviously that's not easy to read right now on stream. That's kind of this experiment a bit. I think what I'll do, let's see, what if I increase it? The main thing is I want it to probably fit within this little vertical, right? It might be off the screen a little bit. So what if I zoomed in this way? Here we go. It's gonna be a little bit white, so maybe not the best for viewers, but at least it would show the idea. So I'm thinking I like toggle this on and off. Maybe something like that. Probably crop this too. So it's just datasheet. Something like that. Okay, so what we're looking, wait, what happens if I show the Categories. Not the most readable. Maybe it's readable on stream. I don't actually know. But anyways, so I'm here in the reset control, and we want to go to the registers to look for any registers relating to timers. So we have a lot of clock stuff. This whole thing is about clocks, by the way. In the STM, everything is powered off of a clock and usually have some control over the clock that supports it. So like if it's GPIO, it gets sampled at a clock rate. And you can control that here. I'm thinking it's gonna be a peripheral. So I can see time 1 restart. So we're definitely getting closer. And it looks like these ones are reset. So sometimes this is readable. Okay, cool. Sometimes this category of stuff. Hold on, I'm just gonna. Can I get rid of this? Oh, it's not even showing up on stream. That's so interesting. Whoa. Okay, my mouse right now is holding something on the document, but that's interesting that it's like it's a separate window from Adobe Acrobat itself. Anyways, random tangent. Like it doesn't show up on stream, but that's good actually. I don't want it to be. All right. Anyways, I see timers. This is like the reset. So we want to be able to control this if we want to reset the timer. Okay, so that's good to know. Maybe what we do is we write some notes down, so that way we can like reference it back. So we'll write some notes in the top here. What's this stuff? Assembly coding? It's close to it. It's register level stuff. So we're going to be coding in C, which allows us to still look at memory locations and manipulate memory locations. You could also do this in Rust, and there's probably some other hidden languages that are hidden, meaning that's not really used anymore. But no, this is just C. We're looking at a register of the STM32, and we need to see how to set certain bits to trigger different little hardware circuits. So first we're going to make some comments though. We want to figure out what are the places that are going to be relevant to any timer stuff. Have you done assembly coding though, Samuel? Or you go by Sam? A lot of people I know go by Sam. Okay, hold on. I actually lost it. We're looking for any of these that say time. This is GPIO. Time. Okay, here we go. We got timer. This is gonna be timer enable. Timer enables are gonna be in RCC AP B1ENR. These are very cryptic names, but that's just how they scaled it up with STM because there's just so many registers. GPIO, flash. Okay, so these were all the enable registers. Let's go to these because these look like they're reset registers. This could be relevant to us. Here we go. So that's okay. Hold on. Timer reset. Timer reset. We have some for RCC APB2 RSTR. Okay, a little bit, nothing in depth. For your game dev, you dabble in C++ for fun after work. Yep, that is a fun time. You know, I thought about doing some game dev stuff. I just never did, I guess. I tried it out, did some tutorials a little bit, but ultimately I did a lot of robotics and I like hardware a lot. So I've kind of gone down the coding path of working on hardware-based stuff like this. So I can make circuits and synthesizers. Something about like physically touching the things you code is like a totally different feeling. It's probably pretty similar in the game dev world actually. At the end of the day, I just prefer hardware. I couldn't really see myself doing web dev stuff. Oh, here's some more timer resets. We should write this down. Timer resets. Timer reset at RCC APB1RSTR. Yeah, but have you been doing game dev stuff for long? I think that's gonna be all for the timer. All the timer stuff that's in this set of this category. Let me look if there's any like speed things. Because the things, oh, here, hold on, what's this? Oh, sleep and stop modes. Trying to buy Raspberry Pi. Oh yeah, those are so popular. It sold out. What's that I pull on the screen? Yeah, so this is the STM32. This is what we're going to be making a coding library for. Basically, this is what you use to do less complex tasks. So the Raspberry Pi has like an operating system on it. You'd hook up like a monitor and keyboard to it. People use it to make like NESs or Game Boys, or also like network routers, maybe not super advanced ones, but people do it. This has no operating system on it. This would run essentially your assembly code to do very simple tasks, such as turn on and on an LED, make a motor spin, drive. Hold on, let's see if I can show this on stream. If you've ever seen one of these before, 1 second. If you've ever seen one of these before, you can use it to drive these. It's not sold out. These exist pretty much all over. Let me show you real quick. Hold on. Ooh, I wonder. I'm going to try something out here. I wonder if I go to web browser. I see it shows the wrong tab. Actually, this is fine. We can use that tab. Is this just music playing on that? Hold on, let me just put that here. Okay. This is like STM32. These are microcontrollers. There are tons of these. You kind of, this is what you want. Okay, yeah. So like, basically you get these to do really simple projects. Whereas the Raspberry Pi you'd get if you want to do stuff with a screen, pretty much. If you've never done hardware stuff before, I'd highly recommend looking into Arduino. So it's, yeah, that's true. That's true. So if you're familiar with assembly at all, these run assembly code that's written for ARM chips only, whereas your desktop, the Raspberry Pi, many laptops, they're all written for x86 instructions or assembly code, which means you can just use applications that people compiled for that particular chip. The ARM chip has a lot less support. Yeah. So it depends on what your project is. You know, you usually choose a chip based on what you want to learn, what kind of things you're trying to do. In my case, I got this chip because I want to do like synthesizers and make music, guitar pedals, make robotics, a chess timer. That was another thing I want to do. Like, those things don't require an operating system and are not going to be a project that really needs some other application code that is on the x86. You could totally make a chess timer. You can make a GUI application on your desktop that does that, but it's not physical, and that's what I want. I want physical. I like to touch things. So yeah. But yeah, I highly recommend looking into like Arduino if you want to get into the basics of hardware stuff. Raspberry Pi is a good one, but it can be a totally different learning curve. Okay, we're gonna go back to the VS Code screen. So I was looking at this data sheet here, and we found this new page for sleep modes. So I'm gonna make another comment about this. We have timer, sleep, and stop. This is going to be useful if we wanted to make this low power, where we turn certain things on and off, certain hardware pieces on and off, which can be crucial for those low power applications. I don't know if I'll get too deep into that right away, but it's definitely something I want to learn. It's a good skill set. Oh, here we go. We have one timer here, timer 8. So we're gonna write this one down too. Timer sleep stop. Sleep stop. SCC, APB2, SME, and R. So this is enabling the sleep and stop modes. Okay. So you can look here, right? It says timer 17, clock enabled during the sleep and stop modes. We set a 1 or a 0. Okay, sounds good. We'll keep on chugging along here. It's a big rabbit hole. There's lots of videos if you want to like research on it. It's pretty fun, I will say. When you get that first LED blinking, it's a pretty cool feeling because it's like, wow, physics are being controlled by me. I coded those electrons. Don't see anything else. Timer here. So I think we need to go to the actual timer category now. So just so you can see the notes I've been taking so far. I've just been writing this down. Timer enable here at this register, reset at this register, reset at this register. It's funny that some of these end with 1, some don't. It's interesting. Anyway, so these are just for future referencing. I'll save that. What we go to next is our timer. Our timer, what should we call it? Timer category. Sometimes you have to go to the power one too to turn it on, but since we found that RCC register, might not need to do that. Power should be kind of towards the top. A good part of this is going to be me literally just like scrolling my mouse around looking for the damn categories. I'm looking for TIM. Here's towards the bottom, that's why I'm not finding it. Here we go. Now we found the timers. You gotta mess with time 1 and 2 to actually set up. Yeah, exactly. Yeah, so that's like, that's definitely the core of what I need to go do. So we have a few different flavors of timers on this chip. We have some that have some fancy features. Looks like here, this one's 16 bits. Oh, this is our, never mind. This is where we have all the features. 16 bits, counting up and down. Whereas you got these basic ones that only count up, and they set a very simple interrupt. It looks like once it hits that top count. I think for simplicity, we should start with this and then move forward. So I'll just checking out the framing. So let's go and say this. So we want timer 6 and 7. I gotta figure out a better way to do this. I'm over here typing. Timer 6 and 7 are our basic timers. And we want them to be what's the word here? We want to be able to access them. So we have a few, and it looks like the way they schedule or set this up is that the timers, it doesn't matter which one you select. You just put the number here for the X. So like if we were to use a different timer, like timer 15, looks like the register here has the same naming convention. So CR1 for 6 or 7, CR1 for 16 or 17, but just a little more options. So the registers, that's good to know. I might just put this general note here then, where we go timer X underscore CR1, and then X is equal timer number. Okay, This is for our control. Control. It's our control register, where we have things like dithering enabled. We have things like auto reloading, one pulse mode, so you just count up to the top once and then you turn off until you enable it again. We have a second control register. It looks like this one is choosing the mode. This one will be very helpful actually. Control timer 2. CR. And these comments, you know, I might not keep them forever. I'm just kind of keeping them here for now. But yeah, this is more just to like make a more brief, a smaller summary of what's going on. So time CR is going to be our control for mode, such as reset, enable, update. So it says here, so enable is to start several timers at the same time, because they all share. Okay, I see. So how they let me show this on stream because this is actually a cool design. So how they have this set up, I'm now seeing they have one register that's 16 bits wide, and just let me make sure this is true before I go off too far. Yeah. Actually, this might not be true. Oh, this is address offset 4. They're mostly trying to push out something about controlling multiple registers at the same time. Okay, so far I'm not seeing a mode. So I think I was mistaken. Never mind. Yeah. So we'll just go back to this then. Oh, we have our mode selection. In most cases, the counter enable signal useful to start several timers at the same time or to control window in which a slave timer is enabled. It's generated when the CEN control bits are written to. Update event is selected as trigger. Okay. Update request, update interrupt enable. So I think we have to mess with this one first. And then go from there. Because this one actually enables the timer. This one is just for interrupts and DMA requests, which we'll do on our resetting of the timer and like reinitializing everything. It's definitely going to be important for this init function, but we'll keep it off to the side for now. Timer counter. This is where the actual counting occurs. These are read and write. Okay, sometimes that's only read only. Update generation. This bit can be set by software. Reinitializes the timer counter. Oh, that's interesting. The application does not capture my cursor, but it'll... Oh, yeah, it does. Interesting. So when I click on it, that's when it... Okay, I see. Remove that back a little bit. Timer counter, event generation, prescaler. This is going to be useful for setting the speed of it. You can see here there's an equation that uses the value in this register. It uses a different clock which is what I was referring to earlier, where we need to look at the actual RCC register. And I think this is dependent on this, or RCC sets this +1 because we do everything with 0 indexed. But frequency wise, you'll need it to be 1 or more in terms of math to be accurate. Counter value is this one up here. So let's go. I mean, most of them are pretty straightforward. We have, yeah, dude, I gotta get a foot switch or something. I gotta get a foot switch because like I'm switching between, like if I hit that switch, I could just instantly, you know, like pop this off and then go back to the code. But anyways, future investment, time PSC, time X PSC is gonna be our pre-scaler. And we're gonna use that to set our, let's change the order of this. Actually, yeah, let's do control register. Register, control register for mode. Register for mode. Prescaler. Scaler for clock. Oh, or speed. Let's do speed. Okay. Put that little note here because it's applicable to pretty much all of them. Okay. This is an important one. We'll also need the auto reload register. Auto reload register, which will be what we set the initial value for once we are done counting. So this timer is just going to count up. And we need to set, you know, we need to instruct it. What should you load right when you finish your counting? Which it seems to be larger than 16 bits, which I'm intrigued by. Value to be loaded in the actual auto reload register. The counter is blocked while the auto reload register is null. Dithering mode is off. The register holds the auto reload value and those bytes. Oh, if you want to dither. Okay, I see. So I think what this means is if you were to count non-linearly, you could spread it out. Oh, wait. 0 through, oh, 3 through 0 bit field contains the dithered part. Yeah, so if you were to dither, which I feel like makes it so you can jump into fractions of accounts, it's kind of a new concept to me, but they keep mentioning fractional parts. I mean, we can look up dither. Dither. That's for the display controller, which is crazy that some of these have that even built into it. I don't think I got the model with that in there. Oh, okay, it's not even gonna search for it. That shows one of the flaws of Adobe. The search does not work in that way, at least. And I just remembered I'm not showing it anymore. Oop, cancel. Okay. Auto reload. We were looking at dithering. We just won't worry about that right now. I think we'll go just with the non-dithering mode, which means we go through 16, 15 through 0 in terms of this register. That timer. ARR. Prescaler's there. Status register. This is where we see if it overflowed or not, meaning we counted to our value. If we weren't going to use interrupts, we're gonna need to have that. This timer XSR is our status register. Status register. Update interrupt flag. This bit is set by hardware on an update event, is cleared by software. So update interrupt pending. This bit is set by hardware when the registers are updated. On counter overflow, okay. Or when the count is reinitialized by software using the UG bit. And the EGR register, we haven't gotten to that. Oh, that's right here. Update generation. Reinitialize the timer counter and generates an update of the registers. Note that the prescaler counter is cleared too, but the prescaler ratio is not affected. Okay, so you just restart essentially. You load whatever value gets put into this counter, I want to say. Let's make sure there's not another place it could be. I think it's in that counter. That'd make the most sense to me. Let's see, this is auto reload. Yeah. Update. You use time event generation. That's if you, more of the use case if you just gonna interrupt a counter and like start midway through a counter, let's say. That could be pretty handy for some DSP stuff, I'd imagine. Mostly, I mean, it could be, it could not be. I'm not too sure just quite. It's definitely a use case though. I'm gonna write that down though. Update generation. EGR. Okay. A counter, of course. Counter. This is just time X underscore CNT. Prescaler, we wrote that. Auto reload register, we wrote that. We did not write that actually. Auto reload register. That's where we load in our starting value. So if we're trying to define what the topmost value is that we're counting to, I want to say, hold on, let's read this counter. UIF copy. This bit is a read-only copy of the UIF bit of the timer ISR register. Oh, where is that at? We're gonna need the ISR register. That's for the interrupt service routine. And I don't see it on this list. Maybe it's in a different category? Like maybe it's on the first timer page? Ooh, there's a lot more registers for this. That one has DMA and all these other fancy features. I'm not seeing ISR though. Maybe this one works where you simply have to count to the max. That could be possible. When in doubt, read the datasheet. Let's see here. A way to do it is to set ARR to max value, then use CCR as hashtag clock cycles -1. Or number of clock cycle. Why did I say hashtag? Anyways, number of clock cycles -1. So yeah, the AR CCR, yeah. CCR, so if you don't want to start from 0, you can start from basically the bottom end of the counter and count up to the top. That's very true. I haven't decided. I mean, I'm taking the perspective of simplicity first, which from my eyes would be counting from 0 up. But, you know, we can add these features as we please. In our case, I'm mostly looking to see how they describe how to use their timer. So here we go. The CEN and UG bits are actual control bits that are controlled by software. CEN would probably be the clock enable. UG looks like update generation. So you need CN to be high, period, if you ever want the timer to be on. UG is high when you want to start the timer. If CN is off and you turn on UG, my assumption is the timer will not do anything. And I'm trying to see, so they don't really like showcase any different behavior when CEN turns on, when it turns high here on this diagram, right? But instead it's going, it's a requirement for it to be on. Counter initialization. Internal. Okay, this is interesting. Oh, this happens inside. So maybe it takes like one rising edge for the counter to actually load in the new value or load in where it needs to start back at. So you trigger with UG and that takes one more clock cycle to load that in. Looks like these are your main registers for actually writing values. So you got your counter, your prescaler, your auto reload. Counter should be what value is it currently at. Prescaler should be what is the speed at which the counter counts, or at least the factor of how fast it counts. And then the auto reload being where to start the counter. But I'm not seeing a top end counter, like control or data register. Auto reload register is preloaded. Preload register is accessed each time an attempt is made to write or read. So there's a different register. There's a different one. There's a preload register. That's what I think I need to find. The contents of the preload registers are transferred into the shadow register, yeah, which is something we don't control. Each update event, depending on the ARR enable bit in time XCR1. Oh, that could be it, yeah. That's true. What we got? Prescaler division, we can look at that in a bit. Counter mode. Hold on. Counter timing diagram with prescaler division from 1 to 4. Counter registers, the actual thing counting. We set this prescaler register. Timer control. That's ARR. Shoot, I don't know how far back you sent the ARR. Oh, you're saying the load is the ARR? ARR? I guess it could be. Following figures show some examples of the counter behavior for the different clock frequencies or when an ARR is at 36. So do they list it here? I guess not. It's going to be down below us. You just have to assume it. Okay. ARR is 36. So looks like in this case they counted up to 36. Oh, here we go. This proves CEN only. Yeah, so the counter stops counting if you disable CEN. So that talks about that. The 36 is our topmost. So this one just resets to 0. I mean, there's a chance it's always going to reset to 0 in this basic timer. I mean, it is a basic timer. It literally says that in the data sheet. So the max value to count to. I mean, I could see it just being that. You just don't have the granularity of counting from not starting from 0. But I mean, again, that's fine. I'm not seeing any examples that uses a different value to start at. What is this? Counter timing diagram update event where ARP is 0, meaning that the timer preloader is not reloaded. Auto reload preload register. Write a new value here. We wrote 36. 36 is hit. It saw that this is the counter overflow. So it updated on its own. They didn't really change any other bits. They kept this, whatever, is to 0. Oh, dithering mode. Used for adjusting the average counter period when the timer is used as a trigger, especially for a DAC. Well, let's get to that in a second. So the difference here, ARPE 0 and 1. Oh, there's a shadow register now. Instead of updating immediately, okay, I see the difference here. ARP, you can write to it. Now, whether or not the timer immediately changes and restarts, it's dependent. Hey, thanks for the follow. What did I say? I don't know how to say that. Unfortunately, we're ya B141. World record ya B141. That's what else. That must be what it is. Anyways, it looks like the preload register has to get this flag here to determine whether or not it loads instantly or not. Because in this case, it doesn't update. This doesn't get transferred into this register, which is actually what loads into the counter, or not the counter, but the like top counter. It doesn't actually use it until it does an overflow, which F5 is the overflow condition. So, hey, how's it going? I'm trying to think if this is going to be relevant for our first case. We're pretty much going to just assume this is 0, I'd say. ARPE has to be 0, because we want the user to just give a time, and then you can get that time. Now, do we want to do the fancy work of calculating out the time? I don't know. I don't know about that. Like if I give it 10 milliseconds, that certainly achievable, but there's definitely going to be some logic that I have to do to make it like auto-generate all the registers and stuff. I think for just testing purposes, we need to just write to registers to at least know we understand the concepts. So we'll do that. So I'm going to put the datasheet away just for a bit. We're going to get back to the code. Trying to think. Yeah, we'll keep it at this view, I guess. It's nice and center. We need to initialize. Okay? The way we can initialize seems to be turning on these registers up here. So first, okay, this is the challenge, right? We pass in a timer, def. This gets defined by a different file, but you can just pass it in. So we take this timer def, timer, right? And it has all of these registers. Before we even do that, oof, this is where it gets kind of tricky. You're gonna need to do some logic to figure out which RCCs to turn on if you want to keep it all in the same function. Yeah, that's gonna be a tough one. I'm thinking we maybe just make like a timer, a basic timer in it, an advanced timer in it. Because if it's a basic timer in it, we just need to worry about the timer, you know, the two timers that are a part of that category. So we're gonna rename this. We'll just do timer basic init. Okay, timer basic init. We need to change our header. Basic init. Okay. So we said here that we need to go to RCC this register to actually turn on the timer that we're dealing with, these basic ones. So let me find it on my data sheet to the side here. RCC APB RCC APB 1 enable. Here we go, enable clock register. Not this one. This is... We need the next one. We don't need this one. I actually don't know why I wrote down this name. Oh, this is 2. That's why. We want this one. This timer 6 and 7 are in here. So we see here bits 4 and 5 need to be turned on high to turn on. Yeah, here we go. We need to write them to 1 to turn on the clock for those. So we will go to our basic timer and we will go ahead and write to these. So this is in RCC. Oh, hold on. Here we go. RCC. And we're going to go to our oh no, sorry, APB1ENR1. Okay, we're gonna go into here, and we're gonna base it similar to how we wrote this GPIO one, where is it at? Oh, I guess we didn't do the atomic operations through CMSys. We'll just do the regular bitwise stuff. That's fine. Okay. Right, this is the name of it. Okay. So we need to write 1 to timer 1 and 7. So in this case, we know that it's just going to be APB. Luckily, I have a bunch of these peripherals already, you know, macroed out. I just need to make sure I have the same format. One moment. Did I already do? Okay, I mean, this is messy, but yeah, here we go. Like, we have all these macros. This is a very nasty switch case. This needs to be changed a little bit, but it works for our initial design. So it looks like it's the main register name, then the next set of register, or like so the main category, then the register name, then the bit, and then position, just to define that it's a position. So we want RCC underscore AH1B1 APB1ENR1 underscore, and we're gonna do time 6 enable position. Okay, and what we're gonna do is we're going to shift 1 over to this, and this will allow us to enable our timer 6. If you wanted to do 7, well, it's as simple as writing this as 7 instead. So right now, this would initialize both clocks. Now, this is okay for not everything, but in terms of just seeing if it turns on or not, this is fine. Likely, we're just comment out 7 and just work with 6 just to make sure we're good. So we're going to enable our timer for 6. We're looking for one more register. That would be the reset. We need to probably reset this once, or at least make sure it's off. So RCC APB1, APB2 maybe, it could be 1. We'll have to see. Reset register. Okay. RCC APB1 reset 1. We need to see what bit. Is the right one? Yeah. So we're gonna write 1 to RCC. I just want to make sure. No effect. Okay, if I wanted to reset it, you write 1 to this. This bit is set and cleared by software. It looks like its default value is 0s, So we actually don't need to write to here. We only need to write to here if we're going to reset a timer. So what we can do is make another function very similar to this one, timer basic reset. Now this is going to be slightly different from, I don't even know if we need to pass it. Well, we probably do. Yeah, we probably do. This is a reset of like the entire clock. So timer basic reset, this might be more a better name for like clock reset, CLK reset. I think that's probably good because we're gonna have a reset where we need to like just restart the counter. Maybe restart. We'll keep it with this description for now. Maybe change it later. APB1R STR1 underscore, and we want timer 6 reset position. There we go. Restart. Reset timer clock. All right. Same thing would happen. We're going to comment out 7. Likely we're going to need to have some conditional logic that analyzes which timer we pass to it. 7, but that is fine. Count this out. Okay. While we're here, we're going to copy this and put it in our header so that at least we have a thing here. But we can keep it like that. Okay. We enable it. We initialize it. This is going to need more parameters. We're going to need to pass in, you know, its top value, which is an ARRP. Let's go to that. Number 6. Oh, I see. Let's see. Do we need anything in our control register at first? I don't think so. We want dithering to be 0. Its reset values sets always to 0. So dithering disabled, that's fine. Remapping, no remapping. You want copied to this counter register. Oh, it's not countered. That's fine for now. Auto reload, preload enable. Not buffered means it just goes straight in. That's good. That's what we want. 1 pulse mode. Counter is not stopped at update event. Counter is stopped at next update event. We want it to keep counting, so we're going to keep this also to 0. Control register wise, what we'll do is we'll put in, you know, we'll comment out this, but we'll put in, you know, some controls for this register. So now we're in the time. I think it goes like this. Oh, I see. Time 6. Is this how this works? Time 6. Okay, time 6, and then you put in the section you're talking about. Okay, so in our case, CR. What are all these extra stuff? I don't remember seeing 1, 2, 3, 4. I just remember seeing 1 and 2. CR 1. Okay, yeah, that's fine. Or equals, and then what we'll do is like 1 over dithering and let's see, times 6 underscore CR1 underscore. Oh, really? It doesn't have a CR? In C folder, there should be a .h file. Yeah, exactly. I'm utilizing that to its max. All of these like IntelliSense suggestions are from that. Yeah. Okay, hold on. What we got here? CCR is the compare and control value. That's not what I want. I want. trying to see. Do I need to put CR? Let me go into this file. Here. Yeah, I'm using this one right here. Right now, this GitHub repo pulls it in as a submodule, which is a godsend. Let's look for ×6 and then see where that's found in code. There's going to be a lot of instances of it, but this might have helped me out earlier, to be honest. Thinking about it, I could have looked at this instead of the data sheet just to figure out timer 6. Particular registers, 70 instances. So these are all in a register that I don't care about right now. DMA requests, not there. Master mode. That's the line of code you used. CR1C. Okay, hold on. Let's see. So I got. Where's it? Oh, I put base there. Okay, maybe just without. Okay. I see. It's because I had the ×6. So it looks like the macro doesn't take the number for this right there. I just gotta put time CR1 and then it should be CEN. Yeah, there we go. Position. If I did CEN, what is this? What does this equate to? This shifts it over already. Oh, I see. So the macro, I could just skip the macro and just go straight to. I'm debating whether I do this or not. I could go straight to. Yeah, maybe I do that. This or equals to this. This would enable it. Yeah, we'll just do that. So this is to enable the pin. We definitely want to do that. I'm debating whether to write out the other settings and comment them out for now. I mean, they're pretty simple, right? This, if you wanted to do dithering, it's gonna be this CR1 not direction. We want dither enable. Oh, I see. Okay, the position is useful for if you're gonna pass in a parameter and you write 0 or 1 to that. So maybe I'll do that. We'll do this dither enable position, and then we do shift it over. We have my keyboard's a little wonky. Doesn't necessarily take all my inputs. We'll take in a valuable diz enable, a variable called that. We're gonna comment this out, and kind of just do the same for a lot of these. CR1 is dead code at the moment. I mean, not dead code, calling out code. I'm not really gonna use the remapping too much. Might just keep that out. I could see myself maybe using the auto reload preload buffer. So let's do auto reload preload enable, I guess. Time underscore CR1 auto RP position. Count this out. Also, you want to do that CEN last because the timer starts when you execute the line of code, so you want to have everything set up first. That would make sense. Yeah, that's a good point. We'll set up all these other settings above it. ×6. CR1. Actually, we can just pretty much copy this. I don't know. I'm typing this out from scratch every time. This next setting will be for one pulse mode. I can see myself doing this. Okay. Do OPM is what they call it. Okay. Any other ones? Update request source. This bit allows me to. Okay. If I were to use an interrupt to trigger it, I can use this bit to decipher if I want interrupt or DMA. Oh wait, no, hold on. Any of the following events generate an update interrupt or DMA request if enabled. And those events are counting to the top, setting the UG bit, update generation through slave mode controller. That's where it's set to 0. If you set to 1, only counter overflow underflow generates an update. Okay, so it's more like if you have these other bits changing, like UG, if you have these other bits changing, then you will generate an interrupt. I think most cases, I'd actually want it to be triggering a interrupt. I might just default that to 0 and leave it at that. I don't see myself changing it off of 0 very much, so that's fine. Update disable. This bit is set and cleared by software to enable update event variable. So it's very much like the last one, except not using the DMA or interrupt stuff. This one's entirely on this enable event, not enable, these event system. Again, I'm going to keep that to 0. I use that a lot. And then that's the end of the control register for 1. Control register for 2 is for the mode. And this is where I do think I will be changing stuff a bit. Master mode selection. Let's look at this again. Select the information to send. Reset. The UG bit from timer EGR register is used as a trigger output. Enable. The counter enable signal, timer counter enable, is used as a trigger output. It is useful to start other. I see. So one counter can trigger other counters or other signals. So this is literally generating a hardware signal. Is that what I'm saying here? Are these one hot encoded too? Maybe. The update event is selected as a trigger output. So we're not really going to use this update system. I'd prefer using the interrupts. Sorry, this event system. Clock at a slave timer or the peripheral receiving the timer trigger output must be enabled prior to receive events from the master timer. Must not be changed on the fly. Yeah, I don't see a need to mess this too much. I think our main case. Hold on, this is read write. So yeah, we can write to this. To select the information to be sent in mass to slave timers for synchronization. TRGO. Okay, I see. Yeah, you got it. You got it. It talks about slave timers. Yep. For a basic driver, that's not needed. It's definitely a very handy feature, though. That's pretty cool. Took me a bit to wrap that around my head, but we got it. So we can keep that off, but this interrupt enable we're definitely going to need to mess with. I don't know if we keep this. Hold on, update interrupt enable. So this would just turn on interrupts from my interpretation. And all the stuff you did, we never touched CR2. Got it. Noted. So interrupt 2, I mean, not interrupt 2, what am I saying? Interrupt enable, I'm like pretty sure we need to turn this on, and I feel like you'd want to turn this on before enabling everything. So we're gonna try it out and see what happens. dir or equals 1 shifted over to it, 1 shifted over to time underscore dir underscore uie interrupt enable. Update interrupt is actually what it is. I mean, I'm pretty sure this is used some other stuff. Update interrupt flag. This bit is set by hardware on an update event. It's cleared by software. Okay, so this one I have to clear myself. I want to say you write 1 to it to clear it is what I'm used to, but let's read to make sure that's how it works. Update interrupt pending. This bit is set by hardware when the registers are updated, aka on counter overflow. So you hit the top of your counter when C and T is reinitialized. So count is reinitialized by software using the UG bit. If either of these bits are set to 0, which they are, we didn't change any of those. Okay, so this will go high basically when we reach our counter. Okay, yeah. Yeah. Which, it's been a bit since I've worked with ISRs, but I want to say, oh, hold on. What's up? Hand pink. Okay, hold on. My multi-stream, like Steam Stream Labs, doesn't show up too well. I can see through my preview the message that Scott sent, but the emote doesn't show up. And I see hand pink waving, face fuchsia, wide eyes. Anyways, but yeah, I see you. Anyways, Bob Joe, I'll tell you in the datasheet when you need to write to 1 to clear something. Okay, so I shouldn't assume that unless I see that. Got it. I mean, if it's cleared by software, usually that means it's up to the user, from my understanding. But, I mean, we'll see. Spis read-only copy. Enter value, yeah. Alright. We can... We don't need to do event generation. That's what UG is all about. I think we just... We definitely need to take in a set time for the prescaler. Like, this is a big part of determining our speed. Set prescaler. This is prescaler. It takes in a 16-bit value. You're gonna need to know ahead of time what clock frequency you're running at. In this case, I think I wonder if they have a graphic at all of their memory, not their memory, their timers. I'm gonna guess they don't. I'm gonna open up. It's some hardcore low-level Sheeb. I don't know if that's how you pronounce it, but it sure is. It sure is. We're in the microcontroller bare metal land. Okay, I'm gonna open up this app called STM32 Cube MX. It's what I use a lot of time to configure my timers. It gives me a good visual. So again, we're gonna do a sketchy little screen share where let's see, where could I put this? What would make sense? Let me add a window capture real quick. Screen capture, no, not screen capture, window capture. There we go. That's source. New source is going to be called cube ID, not ID, cube MX is what it's called, cube MX. And it looks like this. It's made in Java apparently. At least that's what OBS said. So this thing, gosh, it's such a scuffed little stream setup. This is pretty funny though. This thing lets me look at my MCU and this cool timer clock diagram. So I'm just going to generate an empty project just to use this tool because it gives me an idea of what would control this timer stuff from a visual point of view. Off to the side, I'm going to just go ahead and select my board real quick. It won't show up on stream, but I mean, it's just a database with a bunch of boards. I happen to know mine off the top of my head, so actually, do I? Okay, here we go. I just need to make sure it had the right RAM setting. Yeah, that's fine. How you doing, Scott? You ever write some low-level code? Are you in the assembly code much, or Rust or anything like that? I know a lot of embedded people have been kind of intrigued by Rust. I haven't gotten into that rabbit hole, but you know, it's not an uncommon thing necessarily. Okay, so from this point of view, we see APB1, and I think if we look here, a lot of our code, we did APB1. You can see here APB1. So that, for looking at this, I have no idea if it's readable on the stream actually, because it's pretty small even on my screen. Maybe if I zoom in, yeah, that's probably better, a little bit better at least. This. Hold on, I just realized I can just put my face at the front. Bear with me. Okay, that's weird. How is it that... Okay, there we go. APB1 takes in APB1 prescaler, and this is the register that we're going to affect, I want to say, which you can go up to this, divide by 16. Does that match up with what our data sheet says? I mean, it has to, but from my understanding, you could set a value that is from 0 to... Oh, I see. The issue is APB1 is not controlled by the same register I was talking about. The register we're talking about actually happens after this. So really, this is like the source. If the source is going to be a certain value, we divide it an additional time. But if I were to set this correctly, I want to say we're running at 160 megahertz. Like, I'm pretty sure I configured everything in my startup code to be 160. So let's go ahead and just like let it auto-generate. It won't be the exact same, but it'll give us an idea of what value it gets to right here. Okay, so it can get to 160 hertz, and it says it right here. But okay, so if we assume we have 160 hertz, megahertz, I should say, not hertz, 160 megahertz, the math becomes a little bit easier on our, calculation. If a user passes in a time, we pretty much could just do a simple equation to equate to that. They would just need to know. They would just need to know the scaling. So, like, if we're doing, I don't know, if you wanted 1 millisecond, you would need to know what to put for that, and then base everything off of that scale. So 1 millisecond might as well just be 1 million. And I think if I'm not mistaken, what we can do is this. Oh, I am such a fool. I just realized I could solve so many of my problems here. Hold on. For Streamwise, I figured out something that would solve a lot. What we'll do is we'll add a display source, but we'll crop it. So display source would be whole, and actually just use center monitor. So we got an ultra wide monitor. This is fine. So you can see here, right? This is what I'm looking at. This long ass thing. What we'll do is crop it. We'll crop it to fit on the stream. Like so. So now this should fit just fine. Let me move it down. We'll hide this. We'll hide this. Okay. There we go. I mean, the colors are a little faded because it's trying to like convert HDR stuff, but I think this is fine. Oh boy, information about update interrupt enable. You enable that when you want to have the reload register reset trigger the interrupt. For a basic timer, that is all you have. For other timers, they have the ability to have multiple different count value triggers. Values trigger the interrupt event. Sorry, I mess up my reading sometimes. And those have their own interrupt enable flags in DIER. Okay, so in our case, you enable that when you have the RR reset trigger the interrupt. So I need to set the A. I think I have it by default setting that. I'm pretty sure because that was that other register. So I do. And we can just use that to validate and like figure out, hey, this is where the interrupt came from. I want to say, I think that's how ISRs work. I could be wrong again. It's been a bit, but I think that's how I want to structure this. Anyways, we can see what I see in real time. That's a lot more helpful. So sick. All right. Back to this. We see 1PB1, APB1. We know it's gonna be 1600. We come over to this. Hey, thanks for the follow. Bob Joe, I thought you were already following me. Oh, you subscribed. I see now. Thanks for the Twitch Prime subscription. Actually, I think that's just a straight up non-Twitch Prime. That's just a straight up sub. I appreciate that so much. Thank you so much. I need to have a... That's a real sub. Yeah, that's a real boy sub. That's right. We got a big boy out here making the big bucks, spending it. We need to make that kind of subscription be a little more pizzazzy. Okay, so back to the core of this. We enabled our timer. Right now, it's just gonna have a straight up normal prescaler, which is fine, but we want the user to be able to change it. So in our case, we need to be manipulating some value in this prescaler. And in this case, the prescaler is like the whole register. So we don't even need to shift at all. Assuming we pass in the correct binary value. So like if we were dividing, let's see here. So if I pull up a calculator, the equation right now. The equation right now is this. Clock source divided by our value, we'll call it x, plus 1, gives you the counter frequency. Freak clock. Right, time. I'll just frequency of our timer. And if you divided it by 1 divided by freak timer should be our timer length, duration, I guess. Timed duration. Tim. Period. I'll do that. Period time. Tim. So, I'll comment this out. So, this we know right now is 16 megahertz. X will be our variable that we will probably take as a parameter up here as a uint 16 because it's 16 bits. So we'll go ahead and set that up. Uint 16T, I think is how, yeah, 16T. This will be our pre-scale. Where? Okay. Prescaler is here, so we'll go prescaler. Prescaler is there. 16 megahertz. Let's say we wanted to get the timer period of 1 second. So 1 second. Let's get out of the programmer one because the division doesn't work too great on this one. All right, 1 second. I just realized here. I'll put it over here. Okay. 1 second. What we're really solving for. Frequency what? Let's just do 1 hertz. So if we're doing 1 hertz, we need 1 is equal to this. So we're just gonna need to invert this, work backwards, some basic algebra here. We got prescaler, you know. Prescaler is gonna be divided by the clock source essentially. Right? Multiply it over there. Actually, wait, no, that's not right. No, yeah, oh. We're multiplying it there. We're solving for a prescale. Yeah, okay. Sorry, I just had to freaking think about that for a second. So this is what we got. It's equal to clock source. It's weird writing out equations in code. I haven't done it too often, really. So we need this variable by itself. Which we can do by just doing this. Prescaler is equal to clock source divided by freak time. I'll just do freak, it's much easier. -1. Okay, and we'll just do clock as well. F will do for frequency. So with this, if we pass in 1 hertz here, clock is 1600, we need 160 million. We need 160 million for this to be 0. So we actually need this to be oh, we are not solving for hertz here. I am now realizing we are solving for a prescaler value. Not quite the same. Counter clock frequency is equal to this equation. Counter clock frequency. Our frequency, we want 1. If we pass 1 here, oh, I see now. Yeah. 1600. Why do I keep saying that? 160 million divided by 160 million subtracted by 1 will give us 0. Now hold on. that means we would just be triggering every single time. That's not really what we want, do we? Does anybody ever have a timer that triggers that fast? I mean, it's... If you do that... You have a really fast timer. Let me just slow down and think about what I'm doing here. Because I do feel like I am over analyzing this quite a bit. Our goal is we want a 1 hertz clock, right? As opposed to a million, 160 million hertz. We have a clock, and we put a 1 here. 160 million divided by 1 is 160 million. So if we wanted a 1 hertz counter, you would need to have a prescaler that is the max value. The prescaler would have to equal 159,999,000, etc. Because it gets added to 1, which is the 160 million, times 1, which is equal to the clock. Okay. And then if we wanted the time, it's just 1 over that, which would be 1 second. We could automate this. I'm thinking about, so I just don't take the prescaler. I take duration, right? Duration or time, length, period maybe. Let's do period. I think period's a better name here. So we take a period. We need to calculate what our prescaler should be. So if we want 1 second, let's do 2 seconds. If we want 2 seconds, that's gonna be equal to 1 divided by 2. Sorry, 1 divided by frequency, the frequency of our counter, which has to be 50, you know? F has got to be equal to, not 50, but, wait a second, it'd be 50 kilohertz, I believe. No, sorry, that's not right. It's gonna be equal to 1/2, but that's 1/2 a hertz. Does that make sense? Yeah, 1/2 a hertz. That does make sense. Because you're slower than 1 second. You're now 2 seconds. What we really want is something to happen, let's say, at 50 milliseconds, 500 milliseconds. If we want 500 milliseconds, this is where we get to 2 hertz. We're at 1/2 a second. So 500 milliseconds. I mean, our equation here is now we just need 1, whatever frequency is frequency, we need 1 over that. So now I think we have our prescaler is equal to, let's see, clock times our time minus 1. Before, if we're solving for 2 hertz, 2 hertz would get put into here, which would be 160,000 million rather divided by 160 million megahertz divided by 2 minus 1, which is the same as, which is equal to 79,999. Which makes sense, right? Your prescaler value counts up to half the amount. The slowest possible count. If you're going to get exactly at 2 hertz, you count up. I see possibly a big flaw here. This does not trigger how long you count, but instead how long it takes to update the counter. So you count for some time. Once you count this many times, you then update your actual counter 1. You know, it adds 1 to it. Then after your clock counts this many times again, it becomes 2. So our equation needs to incorporate that. It needs to incorporate that. This complicates some stuff. This is definitely an equation, but we need to see what our max counter value is to begin with, which I believe would be also 16 bits. And I just double checked and it is. So we have a prescaler, right? Prescaler, which is equal to 160 megahertz. And we have our actual counter, which is equal to 160 million. So if we wanted a time, first let's see if they have an equation that's already in the datasheet. Sometimes they do. Wrong button. There we go. Moment. There's my W reader. Here we go. Just gonna edit something really quick. Oops. Okay. W readers here. We need to see if there's more to this equation. There definitely is, but let's go to the actual description here. Here we go. We need this button right now. It's for dithering. Is this only for dithering? Maybe it is. Dithering is pretending you have more resolution than you actually do. That's a new concept. I'll definitely have to read about that for this application. 20 bits instead of 16. That's kind of crazy. It's pretty clever. However they figured it out. Okay, hold on. Here we go. Counter counts from 0 to auto reload value, then restarts from 0 and generates a counter overflow update. No formula. No formula. Okay. We'll have to be the smart ones to come up with the formula then. frequency, make this a little bit easier on the eyes. T for time, F for frequency, or T for period, really. Just a pre. This doesn't give you a time. This is for time of pre. Frequency of pre. We need to solve for T. I want to say this is just your prescaler. It's the same kind of thing. It's going to be, instead of your clock source is your prescaler. So really it's just the same kind of thing. Instead of clock source, you do pre times your counter. Thanks for this. Oh, thanks for the sub, Philip. Good old resub with that Twitch Prime. Appreciate it. Appreciate it. Appreciate that Twitch Prime. 5 months to 4 months. Thank you. All right. So, anyways, you got the prescaler divided by your counter plus 1. Do we need to probably plus 1? Yeah. Is going to be equal to your frequency of your actual counter, which again can be divided by 1 to get your time, just period. So, you know, this updates, well, how often this updates. The counter is always a fixed amount. Oh no, we can change that amount. Right, we can change that amount. So, let me think about this a bit. We have 2 variables that we can control in order to achieve our time. Ideally, let's get rid of frequency first. So we got pre divided by, actually we want 1 divided by this frequency. So we need to flip this over. Right. Pre is going to be equal to 1, actually just count plus 1 divided by time. So we need time over here divided by pre. Okay. This is the core of the equation. So then if we take this and plug it in here, we should have our full final equation where we have 2 variables that we can control. We pass in a counter value. Oh wait, we want to solve for T. Shoot. Where T is an input and we output is our count. So let's go back 1 step. What we actually need is times pre minus 1 is count. So we have this, right? Our time times our prescaler minus 1 is how much we count to. Makes sense. I multiply this onto the top here. Actually, I brought this over here. T times T. Yeah, and that gets good on this side. Let me subtract. The algebra makes sense to me. So then if we take this, we now have T times this, right? Minus 1 equal to count. Period of the prescaler. Do we need that? Okay, this is a fixed amount. Counter's not a fixed amount. Also, how would this distribute? You're gonna multiply t by all this? I mean, it's got to be a quadratic. You have two variables that you need to solve. So this is like 160 times t. I mean, your t's can be squared, right? Times t pre. So this is your squared part of it. You have the t here, and then you just have -1 here. Equals your count. There should exist multiple solutions for this. But in reality, right, these are clamped. These can only ever be greater than 0. So I think you would still find one solution. That's only assuming that you have the same, like, your period gets passed to both. That seems a little weird. What if we... Automating this definitely seems like quite a challenge. There's a good chance that we can achieve a lot of the times we actually ever care about without changing the prescaler, because we're counting to such a high number. But if we want to go really slow, that's what we care about. Okay, that makes sense. That would make sense. 160 megahertz with a counter that only counts to 1 will get you that 160 megahertz counter. You count to 2, now you have an 80 megahertz counter. If you want to count for like hours, which we kind of do, I don't know if we can reach hours, but I definitely want to like count to full minutes and stuff. We're gonna need these larger numbers. I think you need to be clever and come up with an algorithm that takes the prescaler, it tries its lowest possible value. Actually, it should be the max. Ooh. There's a design pattern that I read about on whether or not you should keep your prescaler higher or lower. If you think about it, if you have, oh shoot, sorry. If you have two counters, you have two hardware points of failure. So if one goes off, it could skew the other. So do you go for the case where you minimize how many timers you're actually controlling, registers you're actually messing with? I mean, the likelihood of that, I don't know how often that is, but it's a legit situation with hardware, I would say. So we could have it where it tries to get a clean number using conditional logic by trying the smallest possible prescaler. I'm just thinking if there's any logic to it the other way. Like theoretically, what you got here is 100. Where's my calculator? Theoretically, what you got here is I think 160 squared. So 2,600,000,000 values that get counted to. That's like the absolute max. So I guess you could say like half of that can be given straight from the counter alone. Whereas the other half, ooh. See, the prescaler is an actual like multiplier though. It's not. It doesn't quite work the same. The situation where you're counting with your regular counter, you go from 0 all the way up to 160 million. Those are your actual seconds, let's say, those actual tick marks. But as soon as you change the prescaler, you're now dividing it. You're doing multiplication rather than addition or subtraction. So that's a big factor, which is why it's a scalar. You're scaling it down. So I think my equation's off here at some point. I think I was treating it the wrong way. Let's kind of back up a bit. At its core, you're taking a variable x. Hold on here. You're taking a wait. I know for a fact you're taking your clock source and you're dividing it by prescalar. Like that's for sure. Which we have here actually. This is your frequency. So your frequency is your counter. Your frequency gets multiplied by your actual counter. I think that would just... Did you divide it? Hold on. So if I'm counting, you know, 1, 2, 3, 4, 1, 2, 3, 4. My output would have to be in this equation like how frequent that counter goes. So if we multiply the frequency and our counter itself, I think we get our frequency of our counter. So theoretically, right, our counter value is going to be 160. Yeah, this is it. This is definitely it. 160. Oh, wait. Hold on. No. If you count to the absolute max value, that's going to be a super slow counter. So I think this is actually your period. So right now we have the use case of 160 for the frequency from the prescaler and 160 of our counter. So you count it all the way to the max. You're gonna be waiting around for 25,600,000,000 ticks, let's say. That's a long time. That's a very long time. But I think this seems right to me. Like only then will you flip the switch. So ideally we want to start, I think, you know, start with f equal to 1 and then gradually go up. Now you see you have the +1 here. So we're gonna do f pre. That's pretty important here. So let's say we have this equation, right? Now we have 160 megahertz divided by pre-scalar value plus 1. Let's do f pre. Actually, pre-scalar. And then this is multiplied by count, CNT. And this is equal to your time. I think we're on a better roll here, right? So this, let's do million here. We'll put clock here just so we have a generic clock. Let's do clock. So we have a generic equation, and then we'll plug in values here. Count we don't know yet. This is million, and it's going to be divided by 2. 0. Assume f pre is equal to 1. Ooh. Okay, so this would have to be 160 million as well. Actually 159.9 plus 1. Let's just do 999, 999. That's the only way we're gonna be able to get this. This seems off. Because this would just be 1 times the count would give you the time. You would get, in this case, I think it's how. Okay, hertz is here. We can't forget the unit, and maybe this will save us. So really, you get 1 hertz is here. Frequency of our timer. So this is a 1 hertz timer. Is that what we have? I think this is what we have. No, wait, shit. There's no way. There's no way. There's no way. Because that would be a very long... It would take forever. Like, if you did max out on both, it would take forever. So this could be seconds. I think this could be... Well, but this, if this is frequency, it can't be seconds. There's just no way. This would have to be frequency. I'm going so back and forth on this. Frequency is how many times something happens per second. Per second is the key word here. This is in hertz. You're multiplying it by your top counter value, let's say. So you're operating something at 160 megahertz. That is really fast. If that becomes 160 megahertz, that is insanely fast. I think you're dividing here then. Your counter... Like, let's just do some simple numbers. Let's say your prescaler... Your prescaler... Its frequency ends up counting every 2 seconds. Or it's at 2 hertz. Right? 2 hertz. So every 500 milliseconds it counts. 500 milliseconds, right? Every 500 milliseconds it goes up 1. Right? Every half a second it goes up 1. And you cap that at 2. Like your counter's top is 2. That means after 1 second, you know, you should get a 1 second timer by doing that. Because you get this, the period of your prescaler multiplied by your top counter, and that'll give you a time. I think I'll just base it off of that. I think that has to be it. So you have T, right? Period of your prescaler times your counter is equal to your time. That's maybe where I got it jacked up. And then if it was frequency, wouldn't that, you would need it to be inverted. So it'd be count divided by frequency equals 1 divided by frequency pre which is the same now as yeah, frequency is equal to frequency pre divided by count. Huh. All right. So if I have a 1 hertz, or sorry, 160 hertz. Yeah, this would make sense. Okay, yeah, here we go, here we go. If we had 100, using that equation, 160 megahertz for our prescaler, and we divide that by 160 million, because that's the top value for our counter, we should get a 1 hertz counter. So this matches up that, because you're counting. Oh wait. Oh wait, frick. This is a fast frequency. Okay, yeah. You're counting really fast because the prescaler triggers that clock source really fast. Then your counter has a really high top value, so you count for a very long time. Those counteract exactly to just happens in 1 second. So, where this all came from? If I pass it in a period, which would be here, this 1 second. If we take this as a parameter, we can do logic where we assume that we'll assume that we use a non-existent prescaler, so it's just going to be 1. And then we adjust the counter to see if we can match that value. If not, we increase our prescaler by 1, and then we'll try again. Let's get rid of this equation. This equation exists. Let's see if we can combine this equation with, this equation with this one. We could start with this actually. So F prescaler. F is going to be equal to clock source, clock we'll just say, divided by PRE plus 1, which is then also divided by CNT for count, which is really just multiplied at the top here, count, and then it's just this factor. So that's the base equation. We know that our clock is always going to be 1600, right? And we want to assume, we'll just do 1600, right, megahertz divided by pre plus 1. And this is going to be times count. This is going to be the frequency of our timer. Algebra is hard. Calculus is easy. That's a famous quote from my high school calc teacher. If we wanted this to be time-based, we just invert it, which would be 1 over this. Right, 1 divided by all this. Oops. 1 divided by all that. Which we can simplify into this. T is equal to, we're definitely going to be dividing by CNT. It's mostly this times 160 megahertz. It's more this pre plus 1. I think it's easier actually to look at it where CNT is in the numerator here. CNT. I think that's way easier to look at. Okay. We'll get rid of the simplification. We just invert this. Yeah, that's much easier. I don't know. I just do that to begin with. All right, prescale plus 1. This is gonna be essentially it'd have to be 159 point or comma 999 comma 999. Count. All right. These basically cancel out. So if we those would cancel out. So if we wanted, right, t is equal to 1 divided by count. If we wanted a 1 second timer, the counter would just need to count to 1. From 0 to 1. Because behind the scenes, this only triggers once this counts up to 160 million. Boom, 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 boom. I think that's fine. If we wanted a counter that went to 2, then we just change this counter to 2. To 2 seconds. To 2 seconds. Or would it be 2 seconds? Ooh. 2 seconds. Because you're going half a hertz. No, not hertz, sorry. You'd be counting up 160 times, not twice. 2. Oh wait, ooh. Does that make sense? Two is equal to 1 divided by CNT. I'm like getting close to it, but then convincing myself otherwise. Point 0.5. 1 divided by 0.5. Would give you 2. You can't count. Can't count a top value that's less than 1. If you count values 2, then you can have. Apparently, you can have. You would be counting twice as slow. So your hertz would have to be 1/2. So now I'm looking at this, I'm like, this has got to be the frequency. Like, I can't see it any other way. But how did this happen is, hey, this is the frequency. It's 2. You're counting twice up. You now count halfway per second. But you don't reach all the way. Which also means you are now at a period of 2 seconds, right? T is equal to CNT. Because that's a crazy revelation if that's the case. If you're counting to 3, you're counting a third of the way up. 3 equals how many seconds? Your count is your period in this situation. If you're counting for less than a second, you have to change the prescaler. There's no other way. You can't go to 0. Count can't go to 0.5. You have to change this value. Which now means, what is hold on. If your timer is this, and you did 160 million divided by 1590, 990. 1, 2, 3, boom, boom. Right? That is multiplied to count now. So your count, let's see, times 2. Oh wait, frick. Times 0.5. Well, you see I really hit a wall here. I sure am a nerd. What are you doing awake? Should be in bed, no? What time is it? It'd be 4 for you, or 3 for you, dude. You back home? Actually, I guess it'd be 2, not 3. I can't even do the basic time conversions. Damn. Are you serious? You're on call? Dude. That's insane. You got like production? Not production, but some server or something went live. That's kind of crazy. You're on call? Damn. They could never do that for me. I'm just so surprised by that. I'm not used to that. Just trying to think, what could it be? We need to be smart about this. Like, I can make timers that are... What if I start from the other side? Instead of assuming my timer prescaler always just goes to 1, what if I... make it start at whatever 1 divided by 160 million is. this would be 1, 2, 3, 4, 5, 6, 7, 8. This is 6 microseconds, 6.25 microseconds. 6.25 microseconds. Refund workflows low success rate went off. Turned out to be due to dependent service being down. I had to go find which ones failed at the step and resume their workflow. So the nightly build failed. Is that what that means? Because if it's workflows, isn't that the GitHub like auto checking on commits and handling some CI/CD stuff? Turned out to be due to dependent service being down. So a different workflow failed, I'm thinking. Is that how I'm interpreting it? I'm not too deep in the workflows, but if it is GitHub workflows, AWS step function. Oh, okay, never mind then. Either way, that is unfortunate. Have you had to do this before, like on calls? I think it's easier if I work in units of time, to be honest. All the time, dang. Yeah, you're grinding out there then. And no, that's just the expectation. Good old Twitch. I mean, Amazon, same thing. Experience some attribution. So I'm on call every 5 weeks. Ooh. I can't speak, but let's see if I can pronounce that. Attrition. Wow, let me Google that. Let me see what that word means. That's a new word for me. It's a big boy word. A big boy word. It's a big boy word. Reduce in numbers. Got it. I see. That is a very politically correct way to word that. But I now see what you mean. You're low. You're low. Your team's shrinked. It's unfortunate. I'm sorry to hear that you are even more busy because of that. Glad that my stream could be here to possibly aid in your time of need. Okay. I'm gonna get back to this. We have a prescaler, and if we have the prescaler count just to 1, meaning its default value, we have it count just to 1. You can't wait. You're taking 2 weeks off after hell yeah. After this on-call shift next Wednesday. I can't wait for you too. A lot of people are taking next Wednesday off. That's like the day at my office too. I won't be, but it's still the holiday season. We all need a break. Breaks are nice. Can't find this. Sure I didn't get any messages, I just realized. This is the lowest possible time. This 6.25 microseconds. This is the lowest possible time that we can make our timer tick. Like that's the fastest time. And if we go up from there, I think we'll be okay. So if this is 1, this is really just 1 out of 16 million. Yeah, 160 million. Oh wait, what the heck? I deleted it? I didn't even pay attention. Okay. This is that. We give it, let's say, okay, I actually think I figured this out, and I mean it this time. If we give it 1 second, let's say, you go to sleep, you'll be in Discord starting next week. Alrighty, that sounds good. I look forward to seeing you there, and I hope you sleep well before you have to get back to the grind. In fact, I should probably sleep soon myself, but after I write this down and commit it, because I think I figured it out. 6.25 microseconds. We want, you know, we're gonna multiply it by something. We want 1 second. Now this is a very small number. Extremely small. Extremely small. Okay. We have point 1, 2, 3, 1, 2, 3, 2, 5, 6. Is that right? I think there's one more 0, 2 more zeros. Right? That sounds right. 1, 2, 3, 1, 2, 3, and then boom. Yeah. So we have this times x equals 1. That's incredibly small. If we divide 1 by that number, we will get what our counter needs to be for 1 second. Yeah, okay, this would make sense. So x is our counter. X is our counter. Which this would match this equation up here. Is prescalar time prescalar. Yeah. By 1. 1 second. Yeah, anyways. Our count, in order for this equation to work, has to be 16 million. Right? And we can do that. We are able to do that. So if we need anything greater, than 1 second, that's when we need to bump up our prescalar up by 1 instead of going hertz wise. So we start with our prescalar being 1, which makes it kind of irrelevant. It counts up to 1, which is at this speed. Incredibly quick speed. Oh wait. Can I just turn it off? Oh no, it's always going to be 1. Because, right now, hold on. I have an example here. I have an example here where they count up. Hold on, one moment. Need to make it so I can see my. Let's do okay. We need one with the prescale register. 0. Alright, counting diagram. Internal clock divided by 1. They're not showing it. Yeah, they're not showing it, but you count up to 36. 36 gets written. We made an assumption earlier. And time count clock is what comes out of the prescaler clock, right? So the prescaler clock controls the time count clock, which controls how often this count register updates. We want to start off where time clock count and time prescaler count are the same. They're the same, meaning they're triggering really quickly. Really quickly. So if we write 0, where'd it go? It's up here. Now it's down in the registers actually. If we write 0 to prescaler, we write 0 here. 0 plus 1. Frequency prescaler is 160. 160 divided by 0 plus 1, which is 1, will give you 160. So you now have a clock that's functionally 160 hertz, which is equal to this count right here. If we increase it by 1, it's now half of that speed. If we increase it by 2, we're now at 3 total, which means now we're a third of this total speed. All right, because you had 360,000 by 3. Yeah. Which means you're now going way slower. You go 3 times as slow, in fact. You get 3 seconds. If you increase it by 4, you get 4 seconds, and so on and so forth. If you want anything more than 160 million seconds, would it be seconds? I mean, this is when your counter is at max value, so yeah. If you want anything more than 160 seconds, which already is how many in hours? So seconds to minutes, this is 2 million minutes divided by 60 minutes in an hour. 44 hours already. Does this seem right? I keep convincing myself it's not right. Something feels off. Your count. 160. 160. And 60 times count. Count is your max counting register. So if it's 1, then you're counting at 125. Actually, if it's 0, really. Well, let's see. Does counting register take? It has to take 0. 0 is definitely an option. It starts at 0. Well, if you give it 1, that's really just be 0. So count, I think is this is in parentheses. Count is actually -1. Because it has an index at 1. CNT is equal to count -1. It's easier to do the math this way. Oh wait, +1. Count. Oops. Count. Nice. +1. Count as 0, then you get. Then you would get, you know, 625 microsecond counter. Which is really fast. So you keep it at that. You increase count a little bit. It's some wild shenanigans. This is like the craziest rabbit hole I've ever been on. Just thinking about it. Kind of funny. I went from registers to this like algorithm that I'm just trying to like come up with this math problem. Just because I'm trying to be clever. I know this has been solved. It's definitely been solved, but I'm like, I want to do it myself. I'm so... I'd be satisfied. Because I know I can do it. Five microseconds. You give it the period of 1 second. In order to solve this, t needs to be divided by 0.25 microseconds and subtracted by 1 to get your count amount. So if you give it 1 second, count's gonna have to equal 500. Yeah, no, 159,999,999. It's gonna have to equal that for this to be true. So what if we just start doing some logic here? So if, you know, if we're given period divided by, oh, this is gonna be some wacky stuff. Do we really want to put division in the source code? I don't know. I don't know, because we're on embedded hardware. It's not like this is an easy operation at all. Right? That's a magic number, by the way. We're gonna have to, you know, fix that later. But if this is less than what? Yeah, if it's less than 0, then we have to increment our prescaler. Is that how it works? Because our prescaler is the number we actually put into it. And if we look here, this is a value put in. It starts at 0. We need to increment by 1. So if the period is less than, then we need to increment by 1. Period needs to be increased by 1. Not period. Our like prescaler which needs to be defined up here. Right, u into 8 underscore t. No, not a. What the hell? 16 t is equal to prescalar. Alright, not equal. Prescalar. Scalar starts at 0. Right, we define it to be 0. Okay. And we got u into 16 t count is going to be equal to 0. So if this is greater than that, we need to plus plus our scalar and try this again. So the equation here is, well, hold on, what is this number coming from? I think actually what we have to do is, if our prescalar, our prescalar is 0. Prescalar is 0? Wait, hold on, we can't just have a magic number there then. We basically need to see this equation here. So this we get by having 1 divided by that. So really it's this times prescalar, because this is our prescalar. But we're actually affecting this number. Prescalar is 0 right now though. Plus 1. Hold on. Prescalar is 0. If we have our prescalar times our clock source, so 160 million, right? This is now how often our source frequency is. Let's see. If we want to go to 1 second, that's fine. Because all we have to do is set our counter to be 0, or to be visible 0 is just the same as 1, which would mean you're utilizing this prescalar at 160 megahertz. This would work. U in 16 underscore t. This is gonna be your frequency. Scalar pre gonna be equal to this equation. Okay. So if your frequency times the period you pass, so 1 second, less than 0. Gonna be divided. Your period's 1. Hold on, something's off. This is 1. Period times how fast. So this is really period times period. So 0.625 microseconds, which is true. You need to increase count. Oh, I see. Okay, so we have two different things going on here. You can increase the counter, or you can increase the prescalar, which we already knew. Also, extra parenthesis here. you like want 1 second, which is, in our case, we're gonna do, shoot, I just realized, how the heck do we even quantify this? You have to do it in units. So 1 unit would be 0.06 microseconds. So if you wanted 1, oh, fuck. If you want 6.25 microseconds, your counter would be need to your counter would need to be 1. Your prescaler would need to be 1. No, actually just your counter. Your prescaler would need to be, no, it needs to be 1 too. Yeah, they both need to be 1. It's effectively 0. They both need to be 0. So, right. You give it a period. Well, alright. Your frequency times your counter your prescaler is 0, which equals this frequency. Your counter is this. Well, I mean, it's 0. That's fine. Just realized. Yeah, this number doesn't actually fit. I don't understand what the error is there. The heck? That's defined there. This is a new term. Yeah, I don't know why that's that. I'm having major brain fog because it's just so late. This is so dumb. I can do this. Oh, it's already midnight. Shrimp. I go. Hold on, I'll be right back. Yeah, mute my mic real quick. Okay, is this thing on? Yeah, it is. Let's see if it works if I go standing mode. I might peek over the top, but we'll see what happens. I'm feeling standing desk mode. Been sitting way too long. Just do that for now. That's fine. Okay. Maybe cut off a little bit. No big deal, right? Can do that. When I get my new camera set up, I mean, I have that camera, but when I have it mounted, I'll be able to probably crop this better. Just like barely. Let's see, is my head's like, because I'm so close. I think this just needs to be a tad bit closer, maybe. Has to be more closer. More closer. How much closer does it need to be? That's insane. I just do this. Okay. That's not very much room for myself, but we'll worry about that later. Okay. Where were we? So this is a task that it's being a little more difficult than I thought, to be honest. I mean, so I've solved this before. I remember doing it in my notebook. I don't have it with me. It's at work. I remember doing this out by hand. I had solved the equations, but in terms of like wrapping my head around it, it got wild. In terms of this, we want to be able to solve wet prescaler and count values to give us the time we desire. And the best way I could figure this out linearly is by trying one case and then for loop increasing it until it fits. You know, you're gonna get some wacky count values, but this is the way I think of. This is the best way I can think of. I know it can be done. In terms of the actual logic, that's where I'm failing. Like the exact equation is where I'm failing, really. Frequency of the prescaler, right? We only want to mess with prescaler if we choose a value. Yeah, if we choose a value that's too big or the original prescaler, then we need to like cut it back some. And it's kind of counterintuitive because you increase the prescaler to make it run less. You decrease the frequency by increasing this prescaler. The prescaler is controlling how fast you count, you tick, you count. Same. I needed a level mind. It's getting way too hyped up. And just be cool with it. So prescaler is 0 here, right? Because we set it to 0. This is 16 whatever, right? If this value is less than 0, then it is impossible for us to reach it, I think. This prescale value is gonna be equal to Well, ideal. If we do 1 divided by, well, okay, we can do this. We can do this. So we have like 1 second. Let's say 1 second divided by this. That's gonna be a really small value if we keep count at 1. But what we have to do is solve first. We need to solve first, then see if it's less than 1. So count. Counter, I guess. U int 16t going to be counter, which is equal to count plus 1. Right? Counter period. So if our counter is 2, well, that doesn't make sense. Hold on, this should be in the denominator, I think, because our frequency is really large here. Our frequency is incredibly large. So I think it's actually period divided by frequency pre plus times counter. Because if counter is 1, this is multiplied 1600, and our actual period is 1, then this is going to be 1 divided by 160 million, which is a very small number. So then, if that's the case, count needs to increase. So we could do some solving. This equation can be solved. Yeah. Yeah. So let's see. I'll do STM32 test. Oh, this is an int, I just realized, which means this division is gonna be whack. Right? 1.6, 10 to the... Yeah. So 1.6, because it would be 16, no, it'd be 160 times 6 zeros. So it's actually, it would be 10 to the 9th. I think 1.6 times 10 to the 9th. The point is supposed to be 160 million. But anyways, if we do, I had it here in a second. What was it? Oh yeah. Test. So if we calculate period, right, divide it by frequency pre times the counter. If anything, I really wanted this to be in a for loop that, well, basically a while, actually, not a for loop. A while. How do we do this? I wanted to loop the prescaler, keep trying to do prescaler value if there's no possible solution that makes our counter value able to produce a timer that is, well, we need a counter value that is not less than 0, because the counter value always has to be greater than 0 up until the max. What we need, we solve once for count is what we really need to do. I need to try and solve for count, assuming frequency pre works. Yeah, I need to solve for count. So we try count, which we defined up here. We're probably going to scale these back down, but just for simplicity of at least making it compile first, we need to do this. Our frequency, we have our period, which would be 1 second, let's say. And actually no, let's say it's, let's say, oh yeah, okay, if it's 1 second, oh no, hold on. Our period, it can be 1 second, but the problem I was saying is 1 divided by this number is essentially just going to be 160 million. 1 divided by 160 million will give you the period of your time. So really what we need is the opposite. Okay, hold on, here we go. Count divided by period, right? So our period is 1 second. 160 divided by 1 second would mean our count has to be 160 million. That's fine because that is greater than 0. So while count, while count, while count is not greater than 0, so is less than 0, but that's not gonna work because count, okay, we need to change count to be a float or something, but now we need, like, do we really want to introduce floating point? I think, gosh, this actually gets really tough. So the issue here is we have integer math that we're dividing with, and if you divide something that's less than 0, it's going to be 0. 0 is a valid value. You can have 0 for this prescaler. It can be 0. I guess what you do is you do the division, right? You do the division, and then you compare that number for count with another thing where you insert 0. To the actual equation and see if the results are the same. It's very messy, and I definitely want to clean it up, but let's just start here. So your count is equal to this, right? 160 million divided by the period, which in our test case is 1 second. That's going to be 160 million. Let's say your period is 6.25 microseconds. If it's 6.25 microseconds, that's gonna that's gonna be a huge number. Shrimp. Because that's gonna be 1 divided by 1600. Sorry, not 16. I keep saying 1600. 160 million. 1 divided by 160 million. If you put 6.25 here, which is going to be that squared, this squared, your count would have to be that squared, which it can't be. It can't be greater than 160. It can't be less than 0. You have both problems now to deal with. Shucks. Right? Which maybe that's fine. Maybe that is okay. But oh yeah, that is okay. Because that means your frequency prescaler needs to go down. Which means you prescaler needs to go up. Oh wait, well, hold on. What the hell's going on here? This is the thing that should be divided. Right, if you increase the prescaler, you are now dividing this in half. So actually it's this. It's this. Because this would be 2, your frequency would be half as much. Yeah, this is right. Wait a second. I'm confident in this part. This part though. You can do this. This is fine. Let's say you want 1 second. 1 second? That's fine. Because your counter's gonna have to equal 160 million. 160 million goes here. Period is 1 second. 160 million divided by 1. That's 160 million for the counter. Let's say your period needs to be 2. That's fine. 160 million divided by 2 is 80 million. That's a fine supported value. If your period needs to be 160 million seconds, that's fine. Your counter now just needs to be... Whoa, wait, what? Your counter needs to be 1 now? Well, that doesn't make sense. If your counter is 1, then... Yeah, wait, hold on, what the hell? If your counter is 1... If your counter is 0, really? Well, yeah, if your counter is 1, then that means you're going to count 160 million megahertz. Is it times here? I think this is times. Oh my gosh, what the heck? Shrimp. Well, that wouldn't make sense either. So if you're... Well, okay, the frequency... Your frequency... We're getting all jumbled around. It's like... I get one idea, and then I go down it. It stops making sense. I like start doubting the math. Period. Period. Frequency prescaler. If you increase your prescaler value from 0 to 1, your frequency now decreases. That would make sense because you're now counting longer. Also, my music stopped. I listen to so much of this music playlist that I'm out. Crazy. Go, I don't know. Epic, dreamy, laid back. I'm probably laid back for now. Okay, that's not quite what I'm looking for. How about you all? Throw on the class. Yeah, ASMR. They have ASMR on here. That's kind of funny. Why am I blanking out right now? Lo-fi house? Sure, this sounds good. There you go, this sounds fine. Okay. Here. So. $160 million. Yeah, like again, I'm confident with this. This seems fine. If our prescaler does not change and we use this frequency pre, you should be able to just multiply that by your now it has to be division in order to get period, at least. Okay, in order to get period you have to divide. So counter definitely. Okay, we're gonna comment this out again. We're back at solving these equations again, but I know I did it. So counter divided by, or so your period has to equal, I think counter divided by frequency. So if you count once, 1 divided by that frequency, yeah, 1 divided by the frequency will definitely give you the period of your timer. Counter being that 1. So multiplying it should work according to this. Yeah, that should be fine. So your period, you pass in the period like this seems fine to me. So now we need to see, okay, well what if your counter, you know, if your counter is less than 0, if counter basically is 0 because this is a uint 8 or 16, so that's an integer, not a float, so it's never going to be less than 0. But you know, if it was less than 0 or counter was greater than 1600, yeah. 1 2 1 2 3. Then what we'd want to do is increase our prescaler a little bit and recalculate this. So really it should be a while this, or maybe a do while, right? Do this. I think this is what we need. If there was float math, we're gonna change this in a bit, but if our hold on, I think I got the syntax off here. I like never use do while, so like I need to actually look this up. This is funny. Do while syntax. Do this while it's that. Okay, yeah. Do this while that. Do counter is equal to this while this. Is that right? That's right. We do want to try it once. wrong with this while here? Something unfit. No, this is all fine. I don't think this is the logic we're quite looking for. I definitely see an issue here. The prescaler should be like, we should try it before messing with the prescaler. So maybe we just do a while. While it's less than that. Add +1 to frequent. Okay, yeah, I think that's. Oh, I just realized it's not quite how this. That doesn't just carry over into this equation. Okay, first of all, we're gonna go back to while. Go back to. Oh, I just realized this whole thing is in for space. Ooh. Ooh. I'll have to fix that later. Damn. Where are we? Okay. While. Right. While this is true, then you would change the prescaler, which is in reality you change this. You're increasing this by 1. Which increases this. So logic here is you take your counter, you try your frequency for your prescaler, you multiply it by a period that's passed in as a parameter. Then you have this times this. This is equal to counter. If that value becomes less than 0, which it would never, or greater than the max, which it would never, then you should enter this. So we need to somehow fix this logic to be more accurate. Maybe we can do it where basically we need to try the equation. If we basically plug in our value again and see if it works. So while counter times period, or so yeah, while counter times period, while counter times period does not equal our frequency. All right, let's see, counter times, no, do counter. Wait a second. I forgot we were scaling everything up. One tick of period you just have to know, or one tick of the counter has to equal 0.256 or something. Ah, shoot, this makes it a lot more difficult. One tick of that. One tick of the frequency. The frequency times 1. Frequency times 1. Oh man, I'm blanking out. Getting sleepy. Counter. Counter. It's multiplied. No. I think I see an issue now. If I pass in 1 for my period, it's not going to be 1 second. Instead, it's going to be one of the counts. So if I pass in 1, actually, hold on. Because if I give it 1, the counter 1, that means your period has to be 6.25 microseconds. Counter has to be 6.25 microseconds. Yep. Wow, counter does not equal. Shoot. Yeah, I could see this thing breaking a lot actually. Because if I pass in just some arbitrary value, there's no way this could have a solution for every possible number. Well, okay, that's when you have to pass in an integer. Fudge. Okay, I think I have to reassess this. I'm like thinking about it, right? You give it some, like you're giving it a period of just some arbitrary value. Doesn't mean much. But like in terms of the user, they're gonna want to just give it some time. I usually use whole numbers. I'm the one mostly using it, I guess. So you're dealing with like whole numbers, I guess. Like you could probably simulate like 5 milliseconds. You could probably simulate 1 millisecond. That's fine. The granularity is fine up until you get anywhere below 6.25 microseconds. That's impossible. But then here's the thing, right? The second closest number you can get is 12.5 microseconds. And then it's 18.75 microseconds. And then it's 25 microseconds. That's 4. That's the count at 4. prescaler still out 0. Count would be 3 actually. Counter would be 4. Count would be 4. Counter would be 4. 25 milliseconds. Equal to 6.25 microseconds. 4 counts would be equal to 25 microseconds. Like, honestly, this is more of the like granularity. So like anything divisible by this, we can definitely, anything divisible by this we can get obviously, but this means we can get like any number over 100 microseconds we can get, which is pretty good. Really good actually. So if you multiply this by 4, 16 counts is 16 is equal to 100 microseconds. That's pretty granular. And I'm just thinking like that only works when the prescaler is set to 0. The moment you change it by 1, you're now doubling it. So now this is 1250, this is 50, this is 200. Like it jumps up immensely. So like I'm in a moment where maybe I just pass it in myself, like I compute it myself, but I don't know. Like I feel like it should be automated. At the end of the code, like, do I really want this to be in the source code? Because this is like, I mean, you only run this function once when you're initializing, ideally. So it's okay, like it would affect startup time, but outside of that, I think it's fine. It's tough. It's a tough situation. And I'm just gonna keep saying that because it is. It's very tough. It's like easier to find issues with it than find a solution. I think what I need to do is just come back to this. Like I definitely see the issue, but I'm not fully determined that like this is a failure, a failed attempt, you know? Like I think this is fine. Do I already have a? Yeah, I have a definition there. Okay, or declaration there. So what we'll do instead is let's see, is there any cons here I should get rid of? Because there might be some redundant information here. I might get rid of this, yeah. And I think I might get rid of this. Maybe not. I think this is fine. We can keep this here. I think we commit this. And yeah, we come back another day. So let me just commit this. So let's see, git add. Change our directory to our BSP. Oh, I actually didn't need to do that. Git add BSP. Git commit. Initial prototyping timer basic timer. Actually, just timer algorithm. init algorithm get push origin main. Okay. Yeah, I think I'm gonna go to bed. I appreciate if anyone's still around. There's a lot of thinking I had to do, and fortunately I couldn't figure out this part of it, but you know, this is just how it goes sometimes, you know? You research a bit, you try out the algorithms, you try and figure out, you know, what the solution is, and sometimes you just need a fresh mind. So we'll leave it at that. We'll leave it at that. Oh, interesting. Hold on, let's see how we can adjust our chat on this page. I've never actually used it on this. This is an interesting one. Huh. That's funny. Like, doesn't even fit. Yeah, maybe I need a different chat for this page or whatever, but anyways. What about this one? Hold on. Full screen? Do I have a full cam? I think it's this. Let's do that. Let's add chat, I guess. The same chat. I'm just gonna like put it in the top corner or something, I guess. Seems fine to me. Okay, anyways, I'm gonna get off. Thanks for watching, everybody.